Hello fellow students, today we are going to talk about integration by parts. So the first thing you need to know are obviously the formulas for integration by parts. This is the three formulas you may see. They are all equivalent form, just written out differently. The first one here is the one using in the textbook. It says u v prime dx equals uv minus u prime v dx. And u and v are functions of x. And the second one here is the shorter one, and the one I'm using is u dv equals uv minus v du. So why this form are they equivalent? It's basically if you have on the first one, if you have v prime, this means the derivative of v with respect to x, so you can write it as dv dx. And now if you just move the dx to the left hand side, you will get v prime dx equals dv. So now you see why you can replace the v prime dx with dv here, and it's the same as the du here. So this one is very short and elegant to use. And the third one, this form is very explicit, and it's the one will be given to you on the formula sheet. So you don't need to write this formula down. Remember, it will be given to you. It says f prime of x, g of x dx equals to f of x times g of x minus f of x times g of prime of x dx. So this integration by parts is useful when you need to integrate two different functions, and they are not related by derivatives, so you can't use u sub. So what does this mean is, if you have to integrate this function, sine of x divided by cosine of x, this is technically two different functions multiplied together, because divided by cosine is basically multiplied by the reciprocal for cosine. But because the derivative of cosine is negative sine, so it's basically related by simple derivatives, and you don't need to use different integration by parts in this case. You can just use u sub. But for more different functions and harder case, integration by parts is useful. And because you can see there are two functions, u and dv, in the integration by parts questions, you need to choose which one is u and which one is dv. Some questions, if they are good, they maybe tell you which is u, which is dv, but some questions you need to choose it by your own. And how to choose it? You just look at it carefully. So the first one, u, you see, you'll be differentiated first. You'll become du here, and then integrated with v. And the other function dv here, it will be integrated on its own, so it will become v here, and then integrated again with du. So therefore, you should choose u such that it will not get more complicated after differentiation, because you need to integrate with v again, and v such that it will not get more complicated after integration, because you need to integrate it twice. So it will be better if this thing will not be very complicated. If you are lucky, v and du, they somehow cancelled in this part, then the work is very easy for you, because this is basically all the hard work. And there is a somewhat useful rule for choosing u. This is based on which of the following function comes first. This is called the I late rule, but I hope you won't be late for your class. This rule is somewhat useful because it works in most cases, but in some difficult cases it may not work. But let's go into the rule. The first one, I, stands for inverse checks. So arc sine, arc cos, arc tan, these things. If you see these things appear in the integral, you should choose them as u first, and choose the other function as dv. And second one, L, stands for logarithms. So for example, the natural log of x. So you should choose it as a u and differentiate it, and then integrate the other part of the integrand. The third case is algebraic. So it basically means the powers of x squared, x cubed, x to the fourth, or something. And this is kind of the middle case. If you choose x squared to be u, then you get du is 2x dx. And then you may need to do integration by parts again to get rid of x. But this one is easy to differentiate, so you can work with it. And the fourth one and the fifth one are the tricks and the exponentials. So for these things, unless the question is very special, you wouldn't want to choose them as your U. You should choose them as your dB and integrate them. And now you may be wondering why the isolated rule works. It's because the first one is cancellation is maybe possible after differentiation. So if you choose U equals natural log of x, so as you can see here, the natural log of x is the second priority, or in some cases it may be the first one. You should choose it as U first. Then du is just 1 over x dx. Because if U is natural log of x, then du dx, if you remember the rules, are just 1 over x. And then if you move this dx to the right hand side, you get du equals to 1 over x dx. And the 1 over x may cancel with the x in b, so your problem will hopefully get easier. And the second point is some of the functions shouldn't be chosen as dv, so you can only choose them as u. So for example, if you choose arctangent to be dv, then it means you need to integrate this function. And if you integrate it, it turns out v will be this, which is a very horrible expression, and you wouldn't want to integrate this again. So you shouldn't choose arctan as dv, you should choose it as a u. Is why the I is the first place in this rule. And the third one, they will not simplify the problem, so don't choose them as u. This is for the t and e section. For example, exponential one, if you choose u equals e to x, then du will be still e to x dx. So the derivative of e to x is still itself. As you can see, this didn't change the problem at all. So in many cases, it wouldn't simplify the problem, and you still wouldn't know how to do the integral. Don't choose them as u unless it's very special scenarios. And there are some caveats I want to talk about for integration by parts. Some questions may require you to use integration by parts multiple times. In these questions, make sure you will stay consistent with u. This is common in the questions with both exponentials and tricks, or with x squared and x cubed. For example, in this integral, ex times sine of x, and you can see both the e and the t in the isolated rule appears. So in this case, it doesn't matter which one you choose to be u. If you want to choose e to the x as u in the first time, then you should choose it as a u in the second time as well. Or if you want to choose sine of x as u in the first time, then you need to choose its derivative, which is a cosine of x as u in the second time. So just make sure you stay consistent with your choice. And the second point, for definite integrals, unlike other methods, integration by parts won't change the limits of integration, and you just need to substitute the limits for u and v straight away. So as you can see, this is just basically the same formula with the lower and upper limits in them. For this part, you just need to substitute b and a into u and v. And finally, as integration parts doesn't really simplify the integral, you should try u sub first if you come upon an unfamiliar integral. So as you can see, integration by parts actually turns one expression, one integral, into two terms. So if you didn't do it properly, it may actually increase your work. So if you can do a u sub, just do a u sub first.